Hey kids, welcome to a day 2 of initial value problems. So this is like applications of initial value problems. We did an application at the end of the last video with a rocket, but this is more like an AP style application. The focus is on the difference between distance, displacement, and position. So I'm going to break up this problem as if it was a long answer, free response question. So it'll have multiple parts and it's going to incorporate some things from both first and second semester, as a free response question often does on the real test. So imagine this was part A of a question on the AP exam, and it was on the calculator portion. So if you don't have your calculator, if you would get it with you, pause and go get it with you, and make sure you're in radian mode, even though it won't really matter for this one. But I'm going to use the calculator throughout it and talk about some keystrokes that might help you with speed. All right, first, I don't need a calculator. It says solve, right? Because just because I have my calculator doesn't mean I use it on every part of the long answer problem. Solve the second order differential equation. Remember, the word solve differential equation just means get the independent variable by itself, get rid of all the derivatives. Second order just means I've got to do the process twice. So I have a second derivative and two initial conditions. So the language here tells you that this is acceleration. You have to know acceleration is the second derivative. So I'm going to use second derivative notation. I'm going to take the derivative, I'm going to say the derivative with respect to the independent variable t of a function I'm going to call y, just because I'm used to it. The second derivative is 3e to the t minus t to the fourth centimeters per second squared. Also tells me I'm a second derivative. And that with the point 0.06, that means at time equals 0, y prime is equal to 6. So I'm going to anti-differentiate acceleration to get me to the first derivative. Undo the second derivative to get to the first derivative. Don't forget plus c. Now I'm going to use 0.6. The 0 is not 0, is it? Therefore, my velocity equation looks like this, but I want my position equation. What do I do? Plus c. Now use 0, -5 is when t is 0 and y. Position equations are often called S. I don't know why. Plug in. Again, don't forget, e to the 0 is not a 0. So I have 3 plus c is equal to -5, so c is equal to -8. So I was given acceleration. I got velocity, and then I got position. This kind of sort of seems familiar, doesn't it? Remember in first semester we did rocket problems and we called those P, V, A? Given position, take the first derivative to get velocity, take the second derivative to get acceleration. We just went backwards. I was given acceleration, you got velocity, and then you got position. OMG. First semester, derivatives. P to V to A, position to velocity to acceleration. Now, second semester, we used antiderivatives or integrals. And we had acceleration, went to velocity, and went to position using IVP, the initial value problems or initial value conditions, because we were given information on both the original and the velocity. OMG. All right, so that was part A, and I didn't use my calculator at all. Part B. On the closed interval, what is the velocity of the particle when its acceleration is at a maximum? Huh? What is the velocity? Note to self. I found velocity on part A. Right? That was the velocity. They want me to plug what is the velocity means I need to plug in to the velocity equation. What do I plug in though? I need to plug in a time, don't I? But I need to plug in a time when acceleration is at a maximum. Now, if you've taken physics, awesome. However, you are on an AP calculus test, a free response where you have to write your calculus knowledge in the directions of the AP exam. It specifically states when you are asked to find a max or a min on a free response, not on multiple choice, on a free response, you are not allowed, even if you have it, to just plug that equation in and look for its maximum. You are not allowed. You must think. Any function, I was given they're asking me about the acceleration function, has a maximum. That's what they were asking me for. At its endpoints, if I'm dealing with a closed interval, and I am, and when the derivative of the function they're asking me about, its derivative, changes from positive to negative. So you cannot just put the velocity function into your calculator and look at its maximum and say, there it is. You can't, but you can use your calculator. But here's how. Here's what they're going to want to see. Look at the equations I've put into my calculator in y1, y2, and y3. Notice that the only equation I've turned on is y3. So I'm going to give you a minute or hit pause. Put these equations into y1 and y2. Do it with me. I put acceleration into y1, the velocity equation we found in part A into y2, and then I let the calculator find the derivative of acceleration. Its derivative. The function they're asking me about, acceleration, its derivative. I put into y3. Now, in truth, the derivative of acceleration was not hard to find. I could have done it myself, 3e to the x minus 4x cubed, right? But I just want to demonstrate that you can have, now this is also old notation, because if you use Math 9, with the newer software, the antiderivative notation comes up, and I think you're pretty comfortable with that, or at least I hope so. I then fixed my window so that I was looking from 0 to 3. And I said, what are my suspects? My suspects are endpoints, where the derivative is equal to 0. And I'm in particular looking for where the derivative changes from positive to negative. There it is. The derivative of acceleration is equal to 0 and changes from positive to negative. Now remember, the endpoints are your suspects as well. The derivative is positive after the right endpoint. That means that 0 is a minimum. The derivative is negative, right? Because if the derivative is positive, it means you're increasing from the left endpoint. The derivative is negative, meaning you're decreasing to the right endpoint. So the right endpoint is also a minimum. Your only candidate for your only suspect that got convicted of being a max was where the derivative acceleration was 0 and changed from positive to negative. I used my calculator to find that 0. And I don't know if this is something that you have been shown before, but if on your graph you used, right, the 0 function to find this x value is now stored in the x cell on your calculator. So you can second quit to your home screen, just call up y2. Why would I call up y2? Because they asked me what is the velocity. So I went to the velocity equation, which is in y2, and I plugged in the x coordinate of where the acceleration derivative was equal to 0. And it spit out this answer. But here's what I write. I did all this work on my calculator. Here's what I write down. Because I have my calculator, I don't have to write the acceleration derivative. Now, I do not round while I'm inside my calculations, but I can round writing down. And remember, on AP, if you round, you must write 3 places past the decimal. And since they gave you units, give them units back. Okay? That was part B. Part C. Part B, they restricted my time to 0 to 3. Part C, they are not restricting my time. They're just saying at 6.5 seconds, is the particle speeding up or slowing down? We did this in first semester with our rockets and with, right, and with Wile E. Coyote. Remember, baby physics. If velocity and acceleration have the same sign, if they're both positive or they're both negative, your particle is going faster. If velocity have opposite signs, positive and negative, or negative and positive, then gravity and acceleration are working against one another. So that's like your rocket shooting off from the ground, but acceleration is negative, pushing it down. The rocket is slowing down the instant it goes off the ground. And then when the rocket goes up in the air, reaches its maximum height, turns around and starts to fall back down to the earth, the velocity is negative because the rocket is going down, and gravity is also negative. So the gravity and acceleration are working together. The rocket is going faster on its way down, back down. That's all AP wants from you. So in your calculator, notice I have acceleration in Y1. I have velocity in Y2. I don't need the derivative of acceleration anymore. I am just using my home screen, calling up and putting 6.5 into both, looking at my answers. I don't need those decimal places, but this is what I write. I don't write this calculator nonsense. I write acceleration at 6.5 was positive. I don't even care what it was. The velocity at 6.5 is negative. Therefore, my particle is slowing. That's all they want from you. All right? Again, first semester. Really, it's just that first semester we started with position. This semester you're starting with acceleration. All right, different example. So clear all that out of your calculator. I have a new equation and they've given me velocity. Remember, velocity is the first derivative of position. So if we were in person, I would do this visual. So you're going to have to just imagine what's happening now. Okay, so I'm going to demonstrate the difference between displacement and distance. So displacement. I'm standing in front of you, in front of the room, and I tell you all to close your eyes. I go 5 steps to the right and 3 steps to the left, and then I ask you to open your eyes. Relative to my starting point, how many steps do you think I took? It looks like I only took 2, right? Relative to where I started, how many steps does it look like I've taken? Whereas distance, I would do the same thing, but ask you to open your eyes. And relative from where I started, how many steps did I actually take? And hopefully you would say, what? Okay, if I went 5 steps to the right and 3 steps to the left, it looks like I only took 2 steps. But in reality, how many steps did I take? Because I changed direction. So look at this velocity graph. Velocity is negative. When velocity is negative, it means your particle is either going down or left. That's what we've agreed negative direction is. When velocity is positive, your particle is going up or right. That's what we've agreed positive direction is. Notice when velocity is 0 and changed from positive to negative, negative to positive, you change direction. You change from going down to up, or you change from going left to right. That's what happens when your velocity is 0 and your velocity changes from negative to positive. So when you are asked, what is displacement? This velocity, remember, is in meters per second. How do you get meters out of meters per second? Anti-differentiate. And you don't care about going down versus up or left versus right. You just want to know relative to where you stopped, how many steps does it look like relative to where you started, how many steps does it look like you've taken from time equals 0 to 3? Without a calculator, this is a very easy function to anti-differentiate, right? T cubed minus t squared plus t, and then you would anti-differentiate that from 0 to 3. So you would plug in 3, plug in 0. Doesn't matter about c because that would cancel out. and you'll get 18 minus 3. And you would put units on your answer. 15 meters is your displacement from relative to where you start. Now, I don't know my starting position, but wherever my starting position was, I took so many steps to the left, so many steps to the right, and then you opened your eyes. It looked like I went 15 meters. Notice how important the x-intercept of that algebra 1 parabola is. Where is that, by the way? I don't care when I'm asking about displacement. Didn't care. But I am now going to ask you about distance. Distance means I need to know how many steps I actually took. If my function was all the way above the x-axis, my displacement and my distance would be the same. But I know without a calculator, 3t squared minus 2t minus 1 is under the x-axis on this interval for part of the way. How do I find where it is? Hello, you took algebra 1 and you paid attention. You don't need the quadratic formula. You can do this very quickly. At time equals 1, the velocity is 0, which is when you turned around. So without a calculator, you need to break up the integral using the properties of integrals from 0 to 1 and 1 to 0. And it's like you want true area. So you negate the negative part, right? If I didn't have a calculator, I would take my antiderivative that I had found from displacement, plug in 1, plug in 0, negate it. Plug in 3, plug in 1, add it. Does it surprise you, giving this graph, that the displacement is less than the total distance? Why? Because you're going left part of the time or down part of the time. That's why. So your total distance is more than your displacement. Now, if you had a calculator in your hands, you would not have to use the properties of integrals. What would you do? If you had a calculator, make the calculator pop this part up. Not differentiable with calculus, but remember, AP allows, the calculator doesn't do calculus. It does really, really good approximations. So it doesn't matter that it's not differentiable there. Your calculator doesn't care. Again, this is the older notation. Just make sure you absolute value the function and then take the antiderivative. Because if you do this, you're going to get 15. Because the calculator is going to do the derivative, antiderivative first, get 15, take the absolute value of 15, and it'll be 15. You need to make sure to absolute value the function and then take the antiderivative, and then you will get 17. Practice that on your calculator, please. Don't forget your units. Same example, but now I want to talk about position. Distance and displacement don't consider where actually did you start. It's just, oh, here's where you started. So for me, I might just consider that, well, that's just a 0. But it doesn't have to be a 0, right? If you are given this function and I'm actually asking you to solve for the position, find the position of the particle at any time t, at any time t, means they want you to solve the initial value problem. Velocity is the first derivative. Solve it by getting rid of the derivative and using your initial condition. Okay, I was fancy and I called my position equation S. You don't have to, you can just call it Y. But here, now remember, I didn't need this plus C when I was evaluating a definite integral. But this time I'm solving the initial value problem. So I have my I took the antiderivative of both sides. Velocity is the first derivative, so when I took the antiderivative, I undid the derivative and just got position. Powered up, plus c, use my initial value. Y is 4 when t is 1, so plugged in 1, solved for c, got c is equal to 5. Therefore, my position equation, there it is. Determine the particle's position at time equals 6. Well, that's no big deal. There you go. Don't forget units. Okay, no big deal. So let's say this was part D. Was it A, B, C? I don't remember. I don't remember what part I was on. This has been a newer question we have started to see on AP. So please star this, highlight it, make note that if it's new on AP, for sure, we are going to assess it as well. Write an integral expression that gets me that position. This is not an integral expression. I evaluated the initial value problem. I solved it. I got an algebra expression. This is an algebra expression. I use the algebra. Oh, I shouldn't highlight it in yellow because it's not. Algebra expression. I plugged 6 into the algebra expression and I got 179 meters. I want to write an integral expression that gets me the same answer when t is equal to 6. So now, position means meters. I was given velocity, so I am sure I am going to have to use the antiderivative of velocity somehow. I just want an expression. I don't have to write equals. But in reality, what I'm after is, oh crap. I want S of t is equal to not algebra. I want S of t is equal to an integral. So think about this. I want this integral to stop at time 6. Where do you think I want to start it, though? 0? Possible. I could, but look here. They've given me an initial condition. So what if I start this at 1? If I say I want to integrate from 1 to 6 of this velocity function, what do I need to add to it? Right? This gets me the displacement. This is displacement, right? I'm not caring about whether I'm going right or left or not. I just want displacement because I'm talking about position. Position. So here's my displacement from 1 to 6, but this time I know at the initial condition, at 1, oh, I don't want that to be red. At 1, I was already at position 4, and then go to 6. Crazy. Now, this is only one possible answer, but it is the fastest. This one was the most efficient answer for this because after all, especially since I went through this trouble up here, I could have done this. Displacement from 0 to 6. But where did I start? Where did I start? At time equals 0, right? Think about this. At time equals 0, where am I? 5. So you would have to add 5 to this. And it's the same situation. Starting at time equals 0, you were already at a position of 5. Then give me the displacement. And there's tons of other things, right? How about this one? What is S of 2? 8 minus 4 is 4, minus 2 is 2, plus 5 is 7, right? Make sure I did that math right. 8 minus 4 minus 2. 8 minus 6 is 2, plus 5 is 7. So another integral expression I could write. Give me the displacement of the velocity equation starting at 2 and going to 6. But what would you have to add? Your position at 2. What was your position at 2? What do we say? At time equals 2, I was already at a position of 7, and then give me the displacement from 7. If you don't believe me, on your calculator, put this equation into y1, and then do each one of these. Do math 9 from 0 to 6 and add 5. Do math 9 from 1 to 6 and add 4. Do math 9 from 2 to 6 and add 7. Each time, you know what you're going to get? You know what you're going to get? You're going to get 179. All of these equal 179. So I've just shown you 4 ways to get 179. The position, not distance or displacement, position at time equals 6. One of them was just algebra, and I gave you 3, and I'm sure you could come up with more, right? How many more could you come up with? Well, infinite. Of an integral expression, right? So make note of these words. We told you AP. We've started to see this kind of question on AP, so we are certainly going to put it on our assessments, okay? So there are handouts that we've created. We first did book problems. Now we're going to do handouts. We have 3 handouts posted on our page, and we're going to do some of it with you in our live session. And I will see you then.